and welcome to Utkarsh Minds Python for Data Science. Today we will see the implementation in Python of hypothesis test Spearman and the effect size. This test is for when understanding the influence of ordinal data on scale data. Since we are working with Python, we will open our Colab notebook and a new notebook. I will give the name to this notebook as ordinal and scale and then click connect. I will upload my data set, which is student statistics. The same data set we have seen earlier in our other exercises. Once the data set is uploaded, we can import our Python files. Number 1, pandas, then numpy, and finally we will need matplotlib.pyplot as plt. Then we will read our data. So pandas dot read underscore csv student statistics dot csv and separator is semicolon, and we can visualize using data.head. So the data is read. We will work with two columns. First is the ordinal data column, which is teach, motivate, and the scale column, which is over grade. So my data dot group by. For each level in the teach, motivate column, we will apply the different aggregate operations on mean, then median, then standard deviation. We will need also mean, and then we will need max. So the name of the data frame is data. Then before that, teach, yes, we will need here to write that we are working with over grade. That's it. So for each level of the ordinal column teach, motivate, we have got the scale data's summary: mean, median, standard deviation, minimum, and maximum. There is one more visualization that we can do. For that we will need the popular library Seaborn. In this we can plot two things. We can plot the histogram. The histogram requires us to specify the name of the data set. Then we need the we will need the x equal to overgrade, and we will need also the ordinal data, that is teach, motivate. We can specify the bins that we want, so number of bins, and last we can specify the multiple argument as fill. When we execute this, we should get our result. See, you can see here the different histograms, but they have we can also make it easier for us to read by changing the argument to stack. So you have the bins. We can see here that from 10 marks to 20 marks, everyone is fully disagreeing that the teacher can motivate. Whereas from 90 marks to 100 marks, we have agree, neither disagree nor agree, and fully agree. So as students start getting more marks, they are saying that the teacher was able to motivate them. There are also other arguments here, like we can say layer like this, and there is dodge, one more argument. So here we can see the levels side by side. One more way we can plot is the box plot. It is an interesting visualization where we have teach, motivate on X and over grade on Y, and we pass the data. So the box plot, it tells us what is the, for fully disagree, when students are saying fully disagree, how much grades are they getting? So they are getting between 20 to 55, whereas students that say fully agree, they are here, they are getting the highest marks. Neither agree nor disagree, they are in this range. So the box plot is giving the range of data. Lower bar is the minimum and above upper bar is the maximum, and these bubbles are the outliers, so we will not see them. The minimum and maximum, this gives us the range, and the other fields, they are the 25 percentile, the median, and the 75 percentile. 25 percentile means 25% of the data is below this level. 75 percentile means 75% of the data is below this level, and this is minimum and maximum. The central line is the median, that means 50% of the data is above and 50% of the data is below. A bit complex to interpret the box plot, and that is why people prefer the histograms. They give a simple picture of the data. So we are interested in applying the Spearman test to understand whether the ordinal data influences the scale variable. So from my ordinal data, I will extract the different unique levels which are fully disagree. From this we will create our coding, which is a dictionary. Here we have to specify that fully disagree is the lowest level, followed by disagree, then neither disagree nor agree is my third level, then comes agree, which is 3, and then comes fully agree, which is 4. Everything else we can discard. So our coding scheme is ready. Now I am creating my a new data set. I will call it my data. So this is just having the two important columns that we want in our analysis. One is teach, motivate, and other is over grade. Only these two columns will be present. Then from the teach, motivate, we want to replace our ordinal data with codes. So from my data, column teach, motivate, I will apply the replace operation and replace the coding. And once I have got that, I will then do my final step, which is apply the function. So new df dot correlation, and here I will specify the method as Spearman. This is one way. Sorry, it is not new df, it is my data. So this is one way of getting the relationship or the relationship between teach, motivate and overgrade, which is 0.7872. Remember that the value of this test is in the form in between 0 and 1. If it is it is between -1 and 1. 0 means no relationship between the two variables. Positive number means when one increases, the other increases, and negative number means when one increases, the other decreases. There are three possible cases. The Spearman row, as given here, is, as I said, between -1 and 1. And whatever I said, I have written here. You can read it later. We have two hypotheses. The null hypothesis says there is no relation between motivation and marks. The alternate hypothesis says that there is a relation. So let us find out. We have one more way of calculating the Spearman measure, that is from SciPy stats import Spearman R, and then from Spearman R we give them the data frame, and since there are some missing values, I will just write nan policy is omit. That means the missing values will be omitted. Sorry, this is my data. Okay, and we have got the same value as for the statistic. The row statistic is 0.78, which we had got even here, and the p value is very less than 0.05. So there is a significant relation, and this significant positive relationship between the teach, motivate and the marks. So the teacher that is able to motivate more, her students or his students are able to score more marks. That is the interpretation of this statistic and p value. Finally, how do we interpret this statistic in terms of effect size? So for effect size, we have the rho as absolute value of this statistic, and then using an if else we can interpret. So if rho this will be rho is less than 0.1, we say the effect is negligible, and similarly we continue the ladder. There are multiple stages here. There is if else if it is less than 0.2, it is weak. If it is less than 0.4, else if, then it is moderate. If it is if I write else if 0.6, then it is relatively strong, and 0.8 is strong, and then we have everything else is very strong. So we did not execute this. We are getting a strong. That means between these two variables that we have here, teach, motivate and overgrade. So teach, motivate has a strong positive impact. Why did I write strong? Because I got the effect size as strong. Why did I write positive? Because the statistic is positive, and impact is because the p-value is less than 0.05. So I will just write here the p-value is less than 0.05, the rho is 0.78, so that people can understand why I am writing this conclusion. Thank you for watching and stay tuned for the next video.